Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Obundele. Current and future water-powered spacecraft, revolutionizing spacecraft propulsion system and making it environmentally friendly. The focus points are as follows: the need for water-powered spacecraft and examples of current and future water-powered spacecraft. Several current and future spacecraft are developed and are being developed to use water as the primary propellant for propulsion. In a water-powered spacecraft, after water is split into hydrogen and oxygen through electrolysis and combusted in the combustion chamber, gases are expelled to generate thrust, which enables the spacecraft to maneuver in space. In future missions to Mars, the Moon, and beyond, water is a promising propellant which could make space travel cheaper and more environmentally friendly. It could be used to power spacecraft for deep space exploration. Water-powered spacecraft could be used for satellites that need to move between orbital altitudes and of different inclinations. Examples of current and future water-powered spacecraft are NASA CubeSat, high spacecraft, MIPRONS water-powered microthruster satellite, European spectral monitoring satellite, and a host of others. The high water-based satellite, a satellite developed by Sony called Sphere 1I, utilized a water-based propulsion system created by the Pale Blue company. This allowed it to maneuver in orbit using water as fuel. The technology was successfully tested in space after the satellite launch on January 3, 2023, marking a significant step towards more environmentally friendly space propulsion. The need for water-powered spacecraft. Water is considered a clean and non-toxic propellant, making it a more environmentally friendly option in comparison to traditional chemical fuels used in spacecraft propulsion. A successful demonstration of water-powered spacecraft will lead to wider adoption of water-powered propulsion systems for further satellite missions, including those requiring frequent orbital adjustments or extended operational lifetimes. The picture here illustrates equilibrium in Moon orbit for water demonstration. Non-toxic water propellant results in simpler, safer, and more cost-effective operations, whether in Earth orbit or elsewhere, as water is readily available on the Moon, asteroids, and other planets. Presently, efforts are underway to develop water-propelled spacecraft for future missions, which will have higher efficiency than chemical propulsion systems and higher thrust than electric propulsion systems. In this picture, we have a rendering of Vigoride, an in-space orbit transfer service for satellites. There are various examples of current and future water-powered spacecraft, and they are as follows: NASA CubeSat, spacecraft, Space Dog, MIPRONS water-powered microthruster satellite, European spectral monitoring service satellite, and Moon water-powered spacecraft. Each of these examples is described as follows. NASA CubeSat. In January 2021, NASA launched a CubeSat into space to test a water-fueled propulsion system. The hydro-sea propulsion system uses water as a propellant to change the CubeSat's altitude and velocity. The CubeSat carries a pint of water in a flexible bladder, solar panels, and the CubeSat power an electrolysis system that splits the water into hydrogen and oxygen. The hydrogen and oxygen are stored in separate bladders and then burned in a rocket engine to create thrust. The picture here illustrates Pathfinder Technology Demonstrator 1 spacecraft, which demonstrated water-based propulsion system in low Earth orbit. The hydro-sea system of the CubeSat was developed through a partnership with TTS Unlimited, and the data collected from the PTD-1 mission will help improve the Hydro-C and Hydro-M systems. The Hydro-M system is planned for future missions, including NASA's Punch mission in 2025. The picture here illustrates CubeSat used in NASA's Pathfinder Technology Demonstrator 1. Sphere I is another example of current and future water-powered spacecraft. The high water-based satellite, a satellite developed by Sony, which is referred to as Sphere 1I, utilized a water-based propulsion system, which was created by a Japanese company known as Pablo, allowing it to maneuver in orbit using water as fuel. The technology was successfully tested in space after the satellite's launch on January 3, 2023. This marks a significant step towards a more environmentally friendly space propulsion. The picture here illustrates Pablo's water thruster used in Sony I satellite for water propellant demonstration. Spacecraft is another example of water-powered spacecraft. A combination of solar power, microwaves, and distilled water managed to lift Momentum Space Vigoride 5 spacecraft thousands of feet above its original orbit using water-based engine in what is a critical milestone. The orbital race was made possible by the company's microwave electrothermal thruster, which make use of distilled water as propellant. The picture here shows Momentum Vigoride orbital transfer vehicle in Earth orbit. Rockets don't always deliver satellites to their target orbits, and this requires the use of space tugs to finish the job. Momentum is seeking to provide exact orbital transportation service, among other in-space infrastructure services, to paying customers. For the latest demonstration, Momentum tested methods and the conditions needed for operational missions, including full power thrust and thrust performed across the anticipated durations. The picture here illustrates Momentum space tugs with a small sat-size Vigoride. Conventional space tugs use rocket engines that rely on chemical reactions to heat propellant. The main system devised in that solar-powered microwaves serve as the onboard energy source for generating the required hot plasma, heating the propellant in order to produce thrust. Momentum is making efforts to support commercial and U.S. government customers. The picture here illustrates Momentum's custom-designed and built water plasma thrusters for its space tugs. MIPRONS water-powered micro-thruster satellite is another example of water-powered spacecraft. MIPRONS is developing water-powered micro-thrusting, specifically designed for phased internet space satellites. MIPRONS propulsion systems patented they've been filed in about 50 countries. In the next steps, MIPRONS is working to validate prototype by testing their propulsion system under terrestrial and vacuum conditions. This project is part of a wider strategy that is focused on the use of water in space, both for propulsion and human applications. Illustration of phased Alenian and MIPRONS water power propulsion system is shown in this picture. European Spectrum Monitoring Service satellite is another example of water-powered satellite. The primary objective of the European Spectrum Monitoring Service satellite that utilizes a water-powered propulsion system is to demonstrate feasibility of using water as propellant in space by performing radio frequency mapping across the European Union while maneuvering its position in orbit using a water electrolysis system in order to generate thrust. The satellite potential aim is to pave way for more sustainable and environmentally friendly space missions in the future. Illustration of Argo space plant to power orbital tugs with moon water is shown in this picture. The main goal of technology demonstration of European spectrum monitoring civilian satellite is to test and validate functionality of a water-based propulsion system in a risk-based environment, including electrolysis process to split water into hydrogen and oxygen, which are used as fuel for thrust. By utilizing water propulsion, the ESMS satellite aims to demonstrate its ability to adjust its position in orbit by performing small maneuvers, which could be crucial for future missions requiring precise positioning. Euclid's mission for measuring plasma distribution, which make use of water as propellant, is illustrated in this picture. Moon water-powered spacecraft are a potential future for space exploration and could be used to power reusable spacecraft and autonomous mining operations. Space plans to build ships powered by water, which will bring things from the Earth to the Moon and back to and fro. The picture here illustrates lunar crater observation and sensing satellite. Space plans a demonstration flight in Earth orbit. After then, the company aims for commercial service. The Moon has ample water ice on the surface, which could be harvested for future missions. Where exactly Argo will land on the Moon will depend on what water resource future spacecraft confirm, whether it be at the poles or in other locations. Illustration of Argo spaceship powered by water that will bring things from Earth to the Moon and back again is illustrated in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to presentation on current and future water-powered spacecraft, revolutionizing spacecraft propulsion system and making it environmentally friendly. Presented by Dr. Ayenshola Ogundele with focus points, the need for water-powered spacecraft, and examples of current and future water-powered spacecraft. Thank you.